Okay, let's unpack this. We keep hearing about these amazing leaps in AI language models.
Right.
One week, a new model can write poetry. The next, it's coding complex software. But how do we really know if they're actually getting better?
Yeah, and what does better even mean in a way we can measure?
Exactly. That's the question we're diving headfirst into today. The essential field of LLM evaluation.
Mm-hmm.
Consider this your backstage pass to understanding how we're putting these powerful tools to the test, separating the hype from genuine progress, all without, getting bogged down in technical gobbledygook.
And what's fascinating is that as these language models become increasingly woven into the fabric of our lives, think about applications in providing information, automating tasks, even creative stuff.
Right, they're everywhere.
The ability to rigorously assess their performance isn't just a nice to have, it's absolutely fundamental.
It has to be.
You need to be able to trust that these systems are performing as expected before we rely on them for, well, important tasks.
Exactly. It's like launching a spacecraft without running simulations first. You just wouldn't.
Right.
Evaluation is the systematic way we put these models through their paces on very specific challenges. It's our way of checking if they can actually deliver on their promises before they're deployed out there.
And we've seen it, haven't we? A model can shine in a carefully crafted demo,
Oh, definitely.
but then stumble when faced with the unpredictable nature of real user queries, or those weird edge cases.
Those edge cases, yeah, they always get you.
So if we step back and look at the bigger picture, evaluation acts like a crucial compass. It shows us where a model excels. And maybe more importantly, where it still has room to grow.
Right, where the weaknesses are.
And this information is vital for developers. It guides their efforts in fine-tuning the models, adjusting the instructions we give them, the prompts.
The prompts. Crucial.
And ultimately making them more capable.
Yeah.
Without the systematic feedback, improving these models would be like, well, trying to navigate in a fog.
Flying blind. And it's not just the folks building these AI systems who benefit, is it?
Not at all.
Think about it. Researchers need to know if their new ideas are actually leading to measurable improvements.
True.
Developers need to catch any accidental drops in performance when they update a model regressions you mentioned.
Yep, super important.
And for you, the person who might eventually use these tools, solid evaluation translates into more reliable and effective AI assistance. You get something you can actually count on.
This leads us right to a core question. What are the actual methods we use to evaluate these complex language models?
Okay.
Our sources point to three main categories. Automatic evaluation, which uses computers to do the judging.
Right.
Human evaluation, where people provide their expert opinions.
The gold standard, some might say.
Often, yes. And the intriguing approach of using language models themselves to evaluate others.
The LLM-as-Judge. Okay, let's start with automatic evaluation. What's the core idea behind using computers to assess language?
At its heart, automatic evaluation uses computational tools and predefined metrics to score a model's performance.
So numbers, basically.
Numbers, yeah. The big wins here are speed and the ability to handle large amounts of data. Scalability.
Okay.
These methods can quickly assess models across vast data sets, and they're generally cost-effective. Makes them ideal for keeping a constant eye on how models are performing as they evolve.
Continuous monitoring.
Exactly. Plus, because they rely on calculations, they offer a consistent and, objective way to measure certain aspects of performance.
That sounds incredibly practical for ongoing monitoring.
There's always a but, isn't there? What are the limitations of letting computers be the sole judge?
Well, the main challenge is that these automated metrics often struggle to grasp the more subtle qualities of language.
Like?
Things humans intuitively understand, like how well a piece of text flows coherence, relevance, whether it really addresses the user's need, or even if it shows any spark of creativity.
Right, the stuff that makes language feel human. Precisely. And there can also be instances where the scores these metrics give don't quite align with how a human would actually perceive the quality of the output. Low correlation sometimes.
Right, so it's like trying to appreciate a piece of music just by analyzing its tempo and rhythm without considering the melody or emotional impact. You miss something vital.
That's a great analogy.
So we need something more. What are some of the foundational automated metrics that keep popping up in the research?
We consistently see a few key metrics. First is perplexity, often shortened to PPL.
PPL, okay.
Think of this as a measure of how surprised a language model is when it sees a piece of text.
Surprised? How so?
Well, a lower perplexity score means the model was better at predicting the next words in that text. It suggests it has a better grasp of the language patterns.
So it's less confused by the text.
Exactly. So it's producing more fluent output. Lower is generally better when it comes to perplexity. Better fluency.
Fluency, that makes sense. Okay, what's next? I keep hearing about BLEU.
Yes, BLEU. It stands for Bilingual Evaluation Understudy. It was initially developed for machine translation.
Right, comparing translations.
But it's become a standard for evaluating various text generation tasks, too. Essentially, it looks at how many sequences of words, they call them n-grams, in the generated text match sequences in one or more human-written reference texts.
Okay, so matching chunks of words.
Pretty much. It's relatively straightforward to calculate, and it's widely adopted, especially for machine translation, text generation, summarization. The core idea is just more overlap suggests higher quality.
So if the AI's words closely mirror those of a human expert, it gets a better score. Simple enough.
Precisely. However, BLEU can be quite sensitive to the exact phrasing used. Even if the generated text conveys the same meaning but uses different words, synonyms perhaps, the score might be lower.
So it doesn't capture semantic similarity very well.
Not its primary strength, no.
Oh.
And it also doesn't always tell us how much of the reference material was actually captured. That's where ROUGE comes into play.
ROUGE. ROUGE. I believe that's another key metric, often used for evaluating summaries.
Exactly. ROUGE, or Recall-Oriented Understudy for Gisting Evaluation. It focuses on how much of the important information from reference summaries is present in the AI-generated summary.
Recall-oriented. Makes sense for summaries.
Yeah. Common ROUGE metrics measure the overlap of word sequences, similar to BLEU, but also things like the longest sequence of words that appear in both the generated text and the reference text.
So it's still about word matching, mostly.
Primarily lexical overlap, yes. While it's useful for determining if the key content has been retained, like BLEU, it's mainly looking at the words themselves, not necessarily the underlying meaning.
Okay. Those sound like the foundational sort of word matching approaches. Now, what about these advanced automated metrics? What makes them more sophisticated?
Good question. These aim to move beyond simple word-by-word or phrase-by-phrase comparisons.
How so?
Well, take Meteor, for example. It considers synonyms and variations in word order. It tries to assess if the meaning is similar, even if the exact words aren't the same.
Okay, that sounds more robust.
And it generally shows a stronger connection, a better correlation with human judgments compared to BLEU. It's used in tasks like machine translation, summarization, even evaluating image captions.
Image captions, interesting. That sounds like a significant improvement. And then there's BERTScore. That sounds like it involves BERT, the model.
It does. BERTScore leverages the power of large language models themselves. It uses the internal representations of words and sentences, the embeddings generated by models like BERT,
Okay.
to assess the semantic similarity between the generated and reference text.
So it's comparing meaning, not just words.
Exactly. Instead of just looking for identical words, it compares the meaning of the words in their context. This makes it more robust to things like paraphrasing.
Right, different ways of saying the same thing.
And it often aligns better with human evaluations, especially in tasks where conveying the same meaning is crucial. The trade-off, though.
Let me guess. Computationally expensive.
You got it. It requires more resources than something like BLEU or ROUGE.
Makes sense, you're using a more powerful AI to judge another AI. And finally, what about these task-specific metrics you mentioned earlier?
Right. These are tailored. They're specifically designed to evaluate how well an LLM performs on a particular task it's built for.
Like what?
For example, in question answering, we might use exact match, or EM. It simply checks if the generated answer is exactly the same as a correct answer in our data. Strict.
Very black and white.
It is. Or for code generation, there's pass at K. This measures the percentage of generated code samples that successfully pass a set of predefined tests.
So does the code actually work?
Exactly. It focuses on functional correctness. These metrics ensure we're evaluating the model based on what truly matters for its intended purpose.
Okay, that gives us a good overview of how computers can evaluate language, the automatic side. Now let's talk about the role of human judgment. You said it's often seen as the gold standard.
It often is, yes. Human evaluation is frequently considered the most reliable way to assess the overall quality of LLM output.
How does it work in practice?
Well, it involves human annotators reading and evaluating the text based on a range of criteria. This can include things like how natural and grammatically correct it sounds, that's fluency, whether it makes sense and is internally consistent, that's coherence, how well it addresses the initial prompt relevance, and critically, whether the information it provides is accurate factual consistency.
So it's much more about getting a holistic impression of the quality. Like, does this feel right?
Exactly. Humans are good at picking up on those subtle nuances and overall quality aspects that automated metrics often miss.
How do they actually capture that judgment? Do they just write comments?
There are different methods. Direct assessment involves having people rate the responses on scales, maybe 1 to 5, for each of those criteria we mentioned: fluency, coherence, etc.
Okay, scoring different aspects.
Right. Another common method is pairwise comparison. This presents evaluators with 2 different responses to the same prompt.
Like Model A versus Model B.
Precisely. And asks them to choose which one is better overall or better on a specific dimension. Sometimes systems like ELO ratings used in chess are adapted for this.
Ah, interesting. Humans can definitely appreciate the more subjective aspects of good language. But it sounds like it can be quite a complex and resource-intensive process. A lot of work.
It certainly can be. Human evaluation can be time-consuming and expensive, especially when you need to evaluate a large number of responses or iterate quickly.
And maybe variability between the humans.
That's another key point. It's important to acknowledge that human judgments can be subjective. Different evaluators might have slightly different criteria or unconscious biases, which can introduce some variability, some noise into the results. Needs careful setup and training.
Okay, so we've got the objective, scalable approach of automated metrics, sometimes missing nuance, and the nuanced, but potentially slower, more expensive, and variable approach of human evaluation.
Right.
Now, for the really intriguing one you mentioned, using LLMs to evaluate other LLMs, the LLM-as-Judge. How does that actually work?
It's a fascinating development. This approach uses the capabilities of one large language model, usually a powerful one, to assess the output of another.
So you feed one AI's output to another AI.
Essentially, yes.
Yeah.
You can provide the evaluating LLM with the original prompt and the generated response, and then prompt it to assign a score or rank different responses.
Okay.
Categorize them based on certain criteria like helpful or harmful, or even provide natural language feedback explaining its reasoning for the evaluation.
Wow. So we're essentially using AI to quality check other AI. That feels recursive.
In a way, yes. This approach offers the potential for more scalable and consistent evaluations compared to relying solely on humans, while potentially capturing more nuance than basic automated metrics.
Best of both worlds, potentially.
That's the hope. These LLM judges can perform fairly nuanced assessments, taking into account factors beyond simple word matching. However, another but.
Always a but.
It's important to remember that these LLM evaluators aren't perfect either. They can have their own inherent biases.
Like what?
Maybe favoring responses that sound like something they themselves would generate, or responses from models trained similarly. There's also evidence of positional bias. They might favor the first response they see, for instance.
Interesting. Like humans, in a way.
And their effectiveness can vary depending on the specific evaluation task they're given. Some tasks they're good at judging, others less so.
So it sounds like no single evaluation method is the silver bullet then. You can't just pick one and be done.
That's absolutely right. A robust evaluation strategy, certainly according to our sources, often involves using a combination of these approaches.
A hybrid approach.
Exactly. You might start with automated metrics to get a broad overview and continuously monitor performance so that speed and scale is useful. And then supplement this with targeted human evaluations or LLM-based evaluations for deeper insights into specific aspects of quality, maybe the ones the automated metrics struggle with.
Got it. So the optimal mix really depends on the specific application of the LLM.
Yes, and the level of detail required in the assessment, and let's be honest, the resources available, time and budget.
Always a factor. Okay,
Yeah.
so we've talked about how we evaluate, the methods, but what are the key things we're actually looking for in an LLM's performance? You mentioned fluency and coherence, but it's more than just getting the right answer, isn't it?
Oh, absolutely. You've hit on a crucial point there. A comprehensive evaluation considers a wide range of factors. Accuracy is certainly important. Does the output align with the expected result? Or factual information, ground truth?
Okay, accuracy is table stakes, maybe.
Often, yes.
Yeah.
But we also need to assess relevance. Does the generated content actually address the user's query or the given context? Is it pertinent?
Makes perfect sense. If it's accurate but answers the wrong question, it's not useful. What else is on the checklist?
Fluency, as we discussed, does the text sound natural? Is it grammatically sound? Is it easy for a human to read? Coherence is related. Is the text flow logically? Is it Internally consistent, or does it contradict itself?
Right, no jarring transitions or self-contradictions.
Then factual consistency is vital, especially for informational uses. Does the information provided align with established knowledge? Does it avoid making things up?
Hallucinations, as they call them. Big problem.
Huge focus, yes. And are there other important qualities beyond just the language itself?
I imagine so. Like, is it actually helpful?
Absolutely. We consider helpfulness the model's ability to actually assist users in achieving their goals. We also want to ensure it provides truthful and transparent responses. Honesty is a key dimension.
Honesty, helpfulness, harmlessness.
Mm.
The HHH sometimes.
That's often mentioned, yes. Harmlessness, being free from offensive, discriminatory, or toxic language, is critical for safety. Bias and fairness are closely related, ensuring the model doesn't exhibit prejudice against different demographic groups.
Crucial ethical considerations.
Definitely. And then there are performance aspects, like robustness. Does it maintain performance even under challenging conditions? Maybe with noisy input or adversarial prompts.
How tough is it?
Right. Efficiency is also important. Speed, latency, how quickly it responds, and the computational resources it consumes.
Practicalities.
And increasingly, there's interest in interpretability and transparency. Can we understand how the model arrives at its outputs? Or is it just a black box?
That feels like a big one for trust.
It is. And the key takeaway here is that the priority of each of these qualities really depends heavily on how the LLM is intended to be used.
Right. An AI summarizing research papers needs high factual consistency, maybe less creativity. An AI generating marketing copy might have different priorities.
Exactly. Context is everything.
Now, I've come across the term benchmark datasets quite a bit in this area. What exactly are these, and why are they so important for evaluation?
Benchmarks. They're essential tools. Benchmark datasets are basically standardized collections of data and associated tasks designed to allow for systematic and objective evaluation of different language models.
Standardized tests for AIs.
That's a good way to think about it. They provide a common ground, a level playing field, for comparing the capabilities of various models across a predefined set of challenges.
So everyone is tested on the same material.
Precisely. This allows researchers and developers to track progress over time, see if new techniques are actually working, and understand the strengths and weaknesses of different models or approaches relative to each other.
Can you give us some examples of these important benchmarks? What do they test?
Sure. For broad natural language understanding, there are well-known ones like GLUE and its more challenging successor, SuperGLUE. They cover a range of tasks like sentiment analysis, question answering, inference.
Okay, general language skills.
Then there's MMLU, the Massive Multitask Language Understanding Benchmark. This tests a model's general knowledge across, I think, 57 different subjects, really broad.
Wow, 57 subjects? That's comprehensive.
HelloSwag focuses specifically on evaluating common sense reasoning in everyday situations, like choosing the most plausible ending to a sentence.
Common sense. Tricky for AI.
Very. The Winograd Skiva Challenge and Winagrande are also about common sense, specifically designed to test a model's ability to understand pronoun references, which requires deeper contextual understanding.
Like, the trophy doesn't fit in the suitcase because it is too big. What is it?
Exactly, that kind of ambiguity. Then there's Truthful QA, which specifically assesses whether a model tends to generate truthful answers, even if those answers contradict common misconceptions found online, trying to avoid mimicking falsehoods.
Important for fighting misinformation.
Definitely. And for evaluating code generation abilities, Human Evil is a well-known benchmark focusing on functional correctness of Python code.
That's a diverse set of challenges. Are these benchmarks fixed, or do they evolve over time as models get better?
That's a crucial point. They do evolve, and they need to. As models become more sophisticated, existing benchmarks can become saturated, meaning top models ace them.
So we need harder tests.
Exactly. New, more challenging benchmarks are constantly being developed to probe capabilities in more nuanced ways. We're also seeing a significant rise in domain-specific benchmarks.
Like for specific industries.
Yes, benchmarks focused on finance, like FinBen, law, legal bench, or medicine, multi-med-QA. These allow for a more targeted evaluation of how well LLMs perform in specialized real-world applications where the demands are different.
Makes sense. You need to know if it works for your specific problem. So we've covered the foundational aspects of LLM evaluation, the methods, the criteria, the benchmarks. What are some of the more cutting-edge areas that researchers are currently exploring? going beyond the basics.
Well, beyond the standard metrics and benchmarks, there's a lot of focus on evaluating more complex abilities, reasoning abilities, for example.
Logical reasoning, math.
Yes, logical deduction, mathematical problem solving, common sense reasoning, multi-hop reasoning where you need to combine pieces of information. There are benchmarks specifically for these like ARC, GSM-8K, math, strategy QA, common sense QA.
Okay, testing the thinking process more directly.
Right. Safety is another huge area. Evaluating toxicity, harmful language generation, benchmarks like real toxicity prompts, BBQ, bias benchmark for question answering, forbidden questions, and the comprehensive safety bench are used here.
Measuring the risks.
And closely related is bias and fairness evaluation, looking for prejudice across different groups using data sets like why no gender, why no bias, crosspairs, and again, BBQ.
Kind of make AI equitable.
Then there's robustness to adversarial attacks. How resilient is the model to input specifically designed to make it fail or produce harmful output? Think self-prompt, prompt bench, adv bench.
Security testing for LLMs?
Sort of, yes. Interpretability and transparency, which we touched on developing methods to understand the decision-making process, like calculating faithfulness scores or checking self-consistency.
Opening the black box.
Efficiency remains important. Latency, throughput, resource use, especially for deployment. And a newer area is tool utilization.
Using external tools.
Yeah.
Like calculators or search engines.
Exactly. Evaluating the model's ability to effectively use external tools to enhance its capabilities. Benchmarks like T-Evil, UltraTool, API Bank, ToolBench focus on this.
Making the AI more capable by letting it use help.
Instruction following is another key area. How accurately can models adhere to complex, detailed user instructions? MIA Bench is one example here.
Can it follow orders?
Essentially. And finally, there's the concept of calibration. How reliable are the confidence scores that the model assigns to its own predictions? Can we trust it when it says it's sure? Methods like temperature scaling or isotonic regression are used to improve this.
Wow. It sounds like the field of evaluation is just as dynamic and complex as the field of LLM development itself. It has to keep up.
Absolutely. And that leads to some emerging trends. We're seeing a strong shift towards more holistic evaluation approaches. Instead of just looking at individual metrics in isolation, the focus is shifting towards comprehensive frameworks that assess multiple aspects of performance in an integrated way. ALM is a great example.
ALM.
Holistic evaluation of language models. It's designed as a living benchmark, continuously updated, evaluating models across a wide spectrum of tasks, metrics, and scenarios. Tries to give a broader picture.
That sounds like a much more complete picture rather than just chasing one score. What else is on the horizon for LLM evaluation?
Well, we're seeing the development of more robust and comprehensive benchmarks generally, including ones that might adapt dynamically based on model performance.
Adaptive testing.
Could be. And benchmarks specifically designed for more complex AI systems like ROUGE systems, retrieval augmented generation, or autonomous agents that need to plan and act.
Evaluating the whole system, not just the language part.
Exactly. And as we discussed, the use of LLMs themselves as evaluators, LLM-as-Judge, is likely to become even more prevalent. There's ongoing research to improve their reliability and address those potential biases we talked about. GEVAL is one framework aiming for more structured LLM evaluation.
Refining the AI judges.
We're also seeing a greater emphasis on ethical and safety-centric testing, bias detection, toxicity measurement, alignment with human values, adversarial robustness. These are moving front and center.
As they should, given the impact.
There's also emerging emphasis on the interpretability of the evaluation metrics themselves. Why does BERTScore correlate well with human judgment? Can we understand that better?
Meta-evaluation.
In a sense, yes. And finally, with the rise of models that can process images, audio, video alongside text, evaluation is naturally expanding to cover these multimodal capabilities. How do you evaluate if an image description is good, or if a video summary is accurate?
A whole new layer of complexity. This has been incredibly informative, really mapping out the landscape. To bring it all together, what are the key things we should take away from this deep dive into LLM evaluation?
I think the most important thing to remember is that LLM evaluation is a critical, complex, and rapidly evolving field. It's fundamentally how we understand the true capabilities and the limitations of these powerful language models.
It's not just about saying Model X is better than Model Y.
Not at all. It's much more nuanced. We've explored the main approaches, automatic, human, and AI-assisted, each with strengths and weaknesses. We've seen the key criteria we measure against, from accuracy and fluency to safety and fairness, and we've touched on the benchmarks used to provide standardized comparisons.
Right. So as these language models become more and more integrated into our daily lives, our work, everything, the way we measure their abilities, their trustworthiness will be absolutely fundamental.
Couldn't agree more.
It really prompts the question, doesn't it?
Yeah.
How will our methods of evaluation continue to adapt and evolve to ensure these AI systems are not only incredibly capable, but also truly reliable, safe, and effective for their intended purposes, aligned with what we actually want them to do?
That's the ongoing challenge.
It feels like a continuous quest, really, to define and measure progress in artificial intelligence, and responsibility hand in hand. If you're interested in digging deeper after this conversation, I definitely encourage you to explore resources like the HellML website, maybe look into some of the research papers on specific methods like GEval, or benchmark suites like SuperGLE or Safety Bench that we discussed. There's a lot out there.
Absolutely. It's a fascinating field to follow.
Well, thanks for joining us on this deep dive into the truly essential world of LLM evaluation.